Now, whiteboard. And now repeat. Suppose that we have that. After the factorization, 3 outside. I suppose que you understand que el least common denominator is 3x minus 2, x minus 3. That part is clear for you or no? Clear that part? Clear, C, no G. This is clear or no? Answer me. LCD is clear or no? Good. Now you're condensing these two fractions in only one, using least common denominator like a common denominator, no? Okay, so now the formula. What is the formula? The formula is easy. Look, the formula you divide LCD divided by denominator 1 and multiplication by numerator 1. Who is denominator 1? This is denominator 1, and this is numerator 1, and this is denominator 2, and this is numerator 2. So when you multiply, or when you divide, sorry, LCD, que es this guy, divided by denominator 1, que es x minus 3, es obvio, let me use in red color, que that part is cancelled. And stay only 3 times x minus 3 times 1 is 3 times x minus 3. Do you follow me? Likewise, LCD divided by denominator 2, multiplication by numerator 2. So when you divide LCD, I'm using blue color, divided by denominator 2, it's obvious that this 3 is cancelled and x minus 3 is cancelled. And stay alive only the red part, que es x minus 2 times minus 2 que we have in the numerator 2. Super clear or super confusing? Entonces less than or equal to 0. So the thing I am doing is condensing in only one fraction. And leave it like that? Of course, no. No. You apply now distributive property, of course, and combine later always, like in algebra, always frequently we are doing 3x minus 9 minus 2x plus 4 divided by 3x minus 2 x minus 3 less than or equal to 0. Okay, almost I finished. Now we combine later. 3x minus 2 is 1x. Negative 9 and positive 4 is negative 5. Wow, fantastic. Entonces, en our numerator, we have only x minus 5. In our denominator, we have 3x minus 3 and x minus 2, sorry, and x minus 3. And this is important. This is our inequality, not the stupid original inequality. Nobody understands. Nobody understands this. This is crazy. This is completely unsolvable. Nobody knows that. However, this is easy. Or relatively easy, according to the idea that we discussed in the last class. You find the critical value numerator is x minus 5 equal to 0. Therefore, x is equal to 5. This is my first critical value. Critical value of the denominator. Bueno, okay. I omit. Bueno, es basically x minus 2 equal to 0 and x minus 3 equal to 0. That means que x is 2 positive and x is 3 negative. Es 0 critical value. Yeah. Es de 0. Critical value by definition is the 0. Ay. Noise. Who making noise?
Y'all happy there's no school, huh?
Who making noise? You lose.
She can't leave because she's going to work tomorrow.
Trinity
I know.
Nelson. Trinity Nelson. No. Putting off the microphone. Pero putting off the microphone, please. Okay. The student Dylan, no? Ask me, critical value is the zero of the numerator and denominator respectively. Yeah. What about these three? Okay, thank you, no problem. What about these three? These three do not participate in the game, yes or no? What do you think? These three do not participate in the game. I can erase them or no? No? Who believe que participate or do not participate in the game? After I want to show you some example. Okay. What is the idea behind this? The idea is clear. Remember, in the table, the factor you write, change the sign, positive, negative, alternating, positive, negative. See, it's positive always. I explained last time that we can delete partial or delete completely. But in this case, 3 is positive, 3 conjugate. Therefore, this do not apport any extra information in the inequality. No apport any extra information, and you can delete. Professor, well, you suppose que es no 3, es negative 3. Well, this is different. It's different because you can delete also, yeah. But you need to reverse the sign of the inequality. Look, this sign is no now less than or equal. No. It's greater than or equal when you delete negative 3. But no, this is not our case. I promise you, I put different example to clarify this idea. So these 3, not necessarily right. So the positive number, totally irrelevant. A negative number, well, you delete, but you change the sign of the inequality. Do you understand this or no? Confusing or no? Clear or no? Let me know. And this is our inequality I need to study. Therefore, I take the expression in the numerator, I put enforce it to be 0. And this is the critical value, 5. And clear so far? Okay, super. Entonces we almost finished, Jaili. 2 and 3 is also critical, but critical of the denominator. Now what should I do? Well, when you get in your hand the critical value, immediately I do the number line. Horizontal line, 0 degree. Something like that. This is my famous all real number line. This is infinity positive, this is infinity negative. In the middle we have 0. And the critical value help me to make a partition 1, 2, 3, 4, 5. This is 2, this is 3, and this is 5. And make a partition. How many partitions? 3 partitions. Why? Because we have 3 critical values. And this is split our number line in 4 intervals. That one, 4 intervals. Yeah, I select totally arbitrary testing point inside each interval. In my paper, I select 1, why not? I select 2.5, why not? It's in between 2 and 3, or 2.6, or 2.1, either way. And between 3 and 5, 4, after the 5, 6, or 7, or 11, or whatever you want. This sketch help me to understand the partition and help me to understand the interval and select the testing point. So remember our famous table. It's easy. You put here TP, testing point, and you list in vertical the testing point 1, 2.5, 4, and 6. And here in the column, well, you put a column que corresponde a every factor in our problem, que es x minus 5, x minus 2, x minus 3, and the extra column que is the total. Maybe you understand much better now. What is the reason I remove that 3? Because this 3 is positive. And suppose I am doing one stupid column of the 3. This column is always positive, regardless what value of the testing point you select. Therefore, this is completely useless. No necessary. Okay, that 3. Total column, yeah, total column, yes, important. Don't push me. I know this. Total now. Plugging in where? Well, plugging in into the factor one by one. Scroll down, step by step. 1 here, plugging in 1 here, 1 minus 5 is negative 4, no? Negative 4, I put negative. 1 minus 2 is negative. 1 minus 3 is negative. 3 negative is negative. And this is important information. That is a risk being close in the circle. 2.5 is negative. 2.5 is positive because 2.5 minus 2 is 0.5 positive. And 2.5 minus 3 is negative. 2 negative is positive. Remember, to know if it's positive or negative, you count how many negative we have in total. We have 3 negative. Odd number of negative. Negative. 1, 2. Even number of negative positive. 4 is negative again. 4 is positive here, and this is positive. 1 negative is negative. And 6 is positive. Therefore, it's obvious it's positive. So we come back at the beginning. Beginning. I take a look. My inequality. My inequality have less than or equal. That means this is important, guys. It's easy. In my opinion, it's elementary idea, but I don't know why the student don't understand. Less than or equal to 0 means that the true guy in this table is the negative guy. See, it's greater than is positive. Okay, this is 0. To be greater than 0, 0 level. To be greater than positive, so above the 0 is positive, and below, suppose que is the level of the sea. Under the water is negative and positive over is positive. Therefore, I indicate the true guy, the testing point que pass the test. It's obvious that this is true. So the negative is true. This is no, this is yes. True. Because my interval, the solution, is the interval, look, is the interval that pass the test. Is the interval in which the testing point is 1. Boom, that interval. Okay? So you take another testing point, the results stay the same. Doesn't change. And another 4. Okay, that interval solution. And 2.5, no, failed the test, and 6 failed the test. Okay, I finished almost. What about the last, the endpoint? The endpoint, look at that, the endpoint, the endpoint, be careful because dependency our inequality is less than, so a strict inequality, or no, it's a combination inequality and equation. But be careful because when you have that situation, it's our situation, that problem, no? So you consider, yes, include the critical value, but only the critical value of the numerator, because the critical value of the denominator is totally undefined. It's never a solution. Therefore, the only critical value que accept this condition is 5. And 5, you put a bracket, en3, en2, no, es paréntesis. Okay, so what is my final answer? My final answer is final answer expressed in interval notation. I asked you in the test, I want the answer in interval notation. You put the expression que corresponde for the first interval, que is from negative infinity, comma, to parenthesis, union 3,5. End the story. So got, so yeah, un gap between 2 and 3. What is the reason gets a gap? Look at that. Let me try to explain what is the reason gets the gap. Look, it's positive. It's positive is the gap. Here, and this is a positive. So as you write the sign. Let me try to do another thing. Some people don't prefer to do the table. I don't know. You put here negative, positive, negative, and positive. Yeah, I know that the true guy is a negative. Therefore, I highlight the solution here and here. But some people doing differently. So doing, for example, you plugging in, if you plugging in directly in our original expression, x minus 5 divided by x minus 3. Again, you can leave. You can leave. Thank you. Yeah. Unbelievable. Okay, she left. Okay, now I say something. I say que es x minus 2 and x minus 3. Suppose. Another way. And it's another teacher, another student doing differently. To say, for example, you evaluate at x equal 1, que es the testing point que I select in the first row, no? Okay, let's do it. Entonces, 1 minus 5 divided by 1 minus 2 divided by or multiplied by 1 minus 3. This is negative 4. This is negative 1. And this is negative 2. Then we have 3 negative. You see we have 3 negative. The answer is negative. And these 3 negative is exactly these 3 negative. Bang, bang, and bang. I don't know why some people like that way. Some people know me like that way. I like that. Do you see or no? Do you see or no? Question. Chinese or Japanese? Everyone understand or no? Come on. No. Yes. Okay. Okay. Super. Okay. I bring quickly. I see very clear from yesterday. Really, Dylan? Wow. And another day was obscure, confusing. Okay, look at that. I bring quickly example of the like a shortcut, no, to do fast without table, no table, no nothing like that. Suppose. Number 1, special. Number 2. Number 3. And number 4 is similar. And number 5, why not? One extra. It's a little bit confusing. Number 5. Okay, is -5 again, x plus 1 square less than or equal to 0. Well, similar like I commented the last time, the numerical value, si it's positive, we can ignore. Because I know perfectly that this guy is positive. Always. However, the thing I need to investigate if the bottom part, that expression is also positive, no? Because positive divided by positive is positive, exactly the same you see in the right hand side. And this is equivalent. When I saw that, in my mind, I delete mentally these 3. But I delete mental also the fraction, because I know that our inequality can reduce it like that. Do you see that? Because 3 is positive. To be should be positive when it's positive in numerator and positive in the denominator, and you express it mathematically x minus 2 positive like that. And you solve this elementary linear equation. And the answer, if you want to express it in interval notation, is parenthesis 2, infinity. And this is the answer of this. Okay, simplification. Only numerator is positive. No. In this example, you see. In other example, let's see. I bring 5 examples to illustrate. In this case, you apply common sense, right? Not too much algebra, not too much table, not too much, no, common sense. So in this case, look, you see that this guy is negative, -5. However, my inequality is less than 0. Okay, this part is equivalent to say to be negative, no? Do you understand that, right? Less than 0 is to be negative, no? Therefore, see the numerator is negative. See the total result is negative. It's because the top part is positive. Okay, it's equivalent to say x plus 1 to be positive. And that's it. Forget -5, forget the rest, the fraction, no. Because x is greater than -1. Okay, and our example is from -1 to infinity. This is special in which you don't need to do because we have only one. I understand. Okay, good. Okay. Let me try next one. Next one look like a little bit complicated because this -5, well, it's obvious it's negative. Okay, this is obvious it's negative. And this guy is obvious is always positive because x plus 1, regardless si x is positive or negative, when you are adding 1 and a square become positive. Therefore, well, negative divided by positive is negative. So this is true always, except one bad guy. What is the bad guy? The bad guy is the critical value of the denominator, que is x plus 1. It's impossible to be 0. So it's x non-negative. How you can interpret this inequality? Well, this inequality we can interpret it like that. This is all real number line. This is 0 in the middle. And in -1, we have a whole in -1. Therefore, my solution is this part and this part. And here we have parenthesis, because I know, okay, -1, we have a whole. Okay, we can indicate like that, but if the test say that you need to express in interval notation, the answer is then from negative infinity, comma negative 1, parenthesis, union, negative 1, comma positive infinity. Like that. Do you see that? And what about this? Well, I suppose it's the same thing. It doesn't matter can you divide or multiply. It's the same analysis. Negative 5 is negative. X plus 1 is always positive. Together is negative. Entonces es always happen except in negative 1, because let me explain. Negative 5, you plug in negative 1 plus 1 is square less than 0, but the number is not 1. No, si the number is not 1, is the same, pero in this case the number is 1, or is 2, or is 3, or is 4, the answer is x is minus 2 or minus 3. Or I need to select one number, guy, to explain this. Okay, the important thing, focusing. Negative 5 is obvious because this is 0 times 0 squared. And 0 squared is 0. And 0 times negative 5 is 0 without sign, because 0 have no sign. And 0 less than 0, this is completely false statement. That means that any value in this inequality is satisfied, so like the green part, except negative 1. Except negative. And what do you think about this? This is similar, very, very similar. I copy intentionally, similar, but I include equal sign. Okay, so again, same analysis. This is negative. This is always positive. But what happens in 0? In 0, yes, because a negative 1 plus 1 is true. Exactly, it's true. Yaeli say, it's true, professor. It's true always. If it's true always, how you write the true? It's because it's equal to 0. Yeah. Okay, 0 less than or equal to 0 is true statement. Therefore, the solution of this weird inequality is all real numbers. So we have no whole. It's from negative infinity to positive infinity. Do you understand this idea or no? Do you understand this idea or no? I know it's complicated. No, complicated, but it's weird. And we're using the common sense, of course. Bueno, let's start doing now the last topic for the test 3, que es system. System of linear equation. I want to recall in 2D. 2D was doing in intermediate algebra, MIT 1033. I want to recall. But the idea in college algebra is 3D. It's a college algebra is 3D, MAC1105. 3D is our problem. But let me recall quickly, of course, 2D. So we have a system, for example, x plus 2y equals 7. This is my first equation. And x minus y equals 4. This is my second equation. And this is the system. My goal is find one value or one ordered pair x comma y such that satisfy both equations. Okay, let's do it. So there are basically two methods. One method is called substitution. Another method is called elimination, but I want to explain substitution now, elimination after, in which, for example, you take the easier equation, que is number 2, in my opinion, and you isolate one variable because the coefficient here is 1 or negative 1. So it's nice to apply substitution. You, for example, you isolate x in the second equation, and x equals 4 plus y. And now you substitution, this is the name of the method, substitution, that expression in another equation, but where? In the x place here. You're right now. 4 plus y. No x anymore. No. Plus 2y equals 7. Well, the rest is elementary algebra. 4 plus 3y equals 7. 3y is equal to 7 minus 4. 7 minus 4 is 3. Divided by 3. Both sides. Wow. Divided by 3. Both sides. Y is 1. Okay, y 1. Therefore, I'm going to find, because it's the ordered pair x comma y, use substitution in either equation. The beauty is that you can use either equation. However, in my opinion, it's easier substitution here because x is isolated waiting for me. So x is equal to 4 plus 1 because y is equal to 1, x is 5. Now the solution is the ordered pair 5 comma 1. Solution. Solution. Do you understand this or no? Do you remember that or no? You remember? Do you remember or no? Yes, clear. Let's do a couple more in 2D to be familiar. No, 3 more. Because I want to cover different situations. So in this case, you have only one solution. One solution. Only one. Because it's the line in 2D and the intersection is the common point. Okay? We have another case. Suppose this is second example in which you have ax minus 2y equal to, this is my first equation in this example. And my second is 4x minus y equal 5. This is the system. Normally we use in curly bracket to indicate that this belongs to the same mathematical object as this linear system of equations. And you have to solve it. You start for the easier equation, in my opinion, is the second. You take advantage that the coefficient here is negative 1. You isolate the y. For isolate the y, well, I copy 4x minus y equal 5. I propose you 4x stay here minus 5 and move y to the other side. Wow, perfect. And this expression is y. And use substitution. Be careful, use substitution, and see you take initially the equation number 2, use substitution, and the equation number 1 is over. No? Use substitution again, equation number 2, because you never get something. And use substitution for the y here, over there. Bam. So my problem is so far ax minus 2 times parentheses 4x minus 5 equal to. Well, distribute the property, why not? And combine like ax minus ax because 4 times 2 is 8 plus 10 equal to. Wow, something weird happened in this problem. The x I try to solve it disappear, cancel out, no more x anymore, and you get 10 equal to this completely false statement. That means when that situation happens is that this system have no solution. No solution. You try to do your best, however, you cannot find solution. And you get in the last moment completely false statement that indicate also que is no solution, solution set is empty set, que is this symbol or that symbol, nothing inside, empty set. This situation happen geometrically speaking when you have two lines parallel. Suppose you have two lines parallel, pam pam, and this line never meets. We have no common point like that, therefore no solution. Okay, this is one solution because we have one intersection point. In this case, no, never we have solution. Okay, okay, I suppose you remember well that part. Now, the third example is similar. 3x minus y equal minus 2, equation 1. 6x minus 2y equal negative 4. That's equation 2. This is our third example. And this third example, again, I saw, wow, fantastic. One here. Isolate the y in the first equation. Entonces, 3x plus 2 equal y. The manipulation was, I move 2 to the left, like a positive 2, and y is negative y to the right. And now substitution. Substitution where? Substitution this and the y of the second equation. Let's do it. So now we have 6x minus 2 times parentheses 3x plus 2 equal negative 4. Equal negative 4. Sorry, negative 4. You apply this trivial property one more time. 6x minus 6x minus 4 equal negative 4. Again, I cannot solve for x because cancel out. But this is different. You have negative 4 and negative 4, because it's true statement. And the interpretation is that we have infinity many solutions. So this system have infinity many solutions. How you can explain geometrically can we have infinity many solutions? Oh, easy. Because you have one line, suppose, that represent the equation 1, and the equation 2 is the same line. Overlap, same line. And the situation happens, so we have infinity solution, because remember, the solution is the common point in between the line. In this case, you have no one, like in the first example, you have infinity many solutions. So how you represent that? Well, you represent that in that way. Es all real number. No es infinity solution, pero no real number. Because this point is solution, pero this point no. And this point no. Entonces, the order pair only such that satisfy either equation, the equation 1 or the equation 2. Okay, by the way, it's the same equation because if you multiply by 2, the equation 1, 2 times 3 is 6, 2 times negative 1 is negative 2, and 2 times negative 2 is negative 4. It's no surprise. This equation is the same, and when you represent on the xy plane, it's the same line. And you copy either equation. What equation you prefer? Well, I prefer the first one. There are no special reason, but I prefer the first one. Okay, it's the order pair such that is on this line, by the way, is exactly the same of the another line, because the only thing I did was multiplication by 2. Everyone follow me? Or no? No? Totally lost? It's hard? It's complicated, that part, or no? You get 5? What 5? 5. Where you get 5? What 5? I don't get any 5. Yeah, you follow me. What 5 you talking about, sir? I don't see any 5. 5. No 5. That 5. That 5. The first example you say. Well, it's easy. Okay. Clifford, you understand where I come from the 5 or no? Yes or no?
I'm talking about the last question you had. It looked like a 5.
Okay. Okay, I take this equation. Look. This equation, okay, is the number 2. Look. I copy again here.
No. Last question.
Okay. But in the last question, I don't see any 5. What is the 5? Here.
I thought that was a 5. Well, you have the coordinate x, comma, y. I thought it was a 5.
Okay.
Yeah.
No. Anyway. Sorry, my handwriting sometimes it's hard to understand. Okay, so you understand. Okay, see, I try to summarize everything in two-dimension problem, 2D. We have three cases. Listen, 2D. When you have two equations and you have one solution. This is unique solution. Okay. And this system is called also consistent. Consistent is synonymous to say that we have solutions. You have at least one solution is consistent. So you have no solution is inconsistent and is independent. Independent means that each equation 1 and equation 2 have completely two different lines, independent. We have another case, this is xy. Again, this is xy. xy. And we have the case in which the lines are parallel. There's no solution. No solution is inconsistent. Inconsistent means no solution. And it's independent also. Yeah, why not? Because we have two different lines, two different equations. However, we have the last case in which you have one equation and the other equation is totally coincident with this. In this case, we have infinity many solutions. Infinity many solution, but that doesn't mean that it's all real number, no, because it's 2D problem, no 1D. 1D is when there's one line and you see from negative infinity to positive. This is 1D, one dimension, 1D. In this case, 2D, it's a plane. Entonces this is also consistent because, by the way, we have infinity solution, bam, 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 bam. This is no solution, but this yes, it's consistent, and this is dependent because the lines are different. Sorry, it's the same. When the line is different, it's independent. When the line is the same, it's a coincidence, it's dependent. Do you follow me? Do you follow me? Okay, now let's continue one more example of the 2D because I want to illustrate elimination method. Elimination method. Elimination method. It's another way. It's the most popular method because substitution is nice. Substitution is good when you have at least one variable whose coefficient is 1 or -1. Otherwise, no, because maybe you introduce a fraction and you complicate your life. So in my opinion, it's much better elimination. Elimination. What is the key idea for elimination? Elimination, the key idea is suppose that you do something, I don't know why, using my common sense and my imagination, and you have two numbers, supposed to 12 and -12, you do something, you do multiplication. You know, okay, when you multiply one entire equation, the equation is the same, doesn't change. It's the same line. I do something using my imagination in order to get exactly the same number and opposite sign, positive 12 and -12. And when you add in this column, the answer is 0. And this is elimination. For example, in this example, I do in different way. One way is using the common sense imagination. Suppose that you multiply the entire equation 1 by 3, it's a new factor, and you multiply the equation, multiply right hand side, every whole equation, right hand side and left hand side, and right hand side. Everything, whole equation. Let's do it now by 4. Because I take advantage. Perfect, thank you. Okay, because I take advantage que 4 is negative and 3 is positive. Entonces, when you multiply, look, you multiply. 3 times 3 is 9. X. 3 times 4, negative 4 is negative 12y. Equal 3 times 1 is 3. And this is my equation 1, exactly equivalent to the original. I change the coefficients, but it's equivalent, it's the same. However, you multiply by 4, the second equation, 4 multiplied by 2 is 8. 4 multiplied by 3 is 12, positive 12. And 4 multiplication by 12 is 48, no? 48. And this is my new equation 2. Okay, I can see, wow, no, I did intentionally. Because when you add in by column, the column of the X is 17. The column of the Y, elimination. I did intentionally. And this is 51. Divided by 17 both sides. X equal 3. At least I have in my hand 3. I'm going to find the Y. You select either equation. I don't know why. In my paper, I select the first one. But the first one, original, not the new one, because the new one have a big number. No, doesn't no good. Suppose 3 times 3, you replace X for 3. Minus 4y equal 1. 3 times 3 is 9. Minus 4y equal 1. So for y in this equation is minus 4 minus 4y is equal 1 minus 9 minus 4y, and 1 minus 9 is negative 8, divided by negative 4 is 2. So what is my solution? My solution is the point or the pair 3, 2. Remember, X component first, Y component second. Any question? Any question? Any question? What part you don't see very well? Clear or confusing? Huh? Exactly. However, let's move on to the 3D problem. 3D problem is more complicated, very, very complicated. Let me try to explain the complication for the 3D problem. I bring one picture to illustrate the complication of the 3D problem. This one. I select this. Boom. Look at that. The problem is that in 3D, each equation represents no line, represents plane, two-dimensional object. And we have more possibility to be one solution or infinity many solution or no solution. For example, in this first example, is no solution because that plane never touched. In this case, it is infinity many solution because the common part is line. In this case, again, it's no solution because the plane yellow and the plane red touch, and the plane yellow and the plane green touch, but the plane red and the plane green don't touch. So to be solution, we need to touch 3 planes simultaneously. This is no solution, this is no solution also, but this, yes, look, this is solution, one solution, unique solution, because let me make it zoom to see more clear. Look, I can see the intersection with yellow, red, and green plane is that point, and this is the solution point. So maybe this solution point we can express it using triple order, X, Y, Z. Okay, this is the idea I want to study. I want to do at least one problem today. Oh, no. 2 problems maybe. Okay? And in the review packet, I promise, okay, do more. Okay, now 3 dimension. Therefore, we have 3 equations. X minus 3y plus 3z equal -4. Equation number 1. And we have 3 equations and 3 unknown, x, y, and z. 3 dimension. 2x plus 3y minus z equal 15. Equation 2. And the last equation, 4x minus 3y minus z equal 19. Equation 3. And this is our system. 3 equations. And 3 unknown. Unknown. Okay? Unknown. It's x, y, and z. Be careful. I want to explain in detail now the manipulation of this. This is a little bit, and you need to follow my recommendation. For example, you pair 2 equations. Can you say +1 plus elimination? Yeah, of course. Of course, Dylan. Pay attention, please. You pair elimination, of course. You pair equation 1 and equation 2. Yeah, I copy separately like that. X minus 3y, sorry, is step by step. So I am very, very meticulous in doing that. 3z equal -4. My equation 1, I recopy again, no? And the equation number 2, I select. But what is the reason? Because I need to be smart. Okay, I select the equation number 2. Oh, because I saw clear like water. Equation 2. Okay, equation 1 and equation 2, when you add in by column of the x, column of the y, column of the z, column of the right hand side, then the y part is ready for elimination. Wow, I take advantage of this. So now this is 3x because 1 plus 2 is 3. The c part is 2c. No, this is 0. I don't want to put 0. 2c equal 11 because -4 is 11. And this new equation I call equation 4 because this is the new equation that comes from the original system when you are doing the combination 1 and 2. And this new equation contains only 2 unknown, not 3. Okay, now you select another couple. Okay, I promise it's the last one. For example, I select 2 and 3. Why I select 2 and 3? This is the most important moment. This is the most important moment in my opinion. It's equation 2. It is equation 3. I select the equation 3 because 3 again is ready for elimination. But this is not the important thing. The important thing is, if I make a decision in the first couple, eliminate y, mandatory, you eliminate y in the other couple. So you eliminate another variable, you are in big trouble. Big trouble. See, I eliminate y here, you eliminate y in the second couple. Oh yes. Now let's do it. Addition by column, always is addition. It's 6x, no y anymore, minus 2z equal 34. Because the 14 carried that 1, 34. And this is equation 5. And that's it, almost I finish. Now you put together equation 4 and equation 5. And we have a system very similar of the system we are doing before. Is 2D because we have two variables only, right? And by the way, this is easy example, not all we have, eh? C is ready for elimination. Positive to C and negative to C. And you adding by column and 9x equal 45. 45, no? 45 because the 5 is 45. Divided by 9 both sides. X equal 5. Oh, at least I have in my hand the value of the one component of the point case. Remember, my goal is find the solution x comma y comma c. I have x in my hand now. Okay. To find, for example, the y and the c, fortunately, you can do in a systematic way, not completely crazy, completely randomly. No. You plug it in the original. No. Why no? Because the original have 3 variables and you have only one in your hand. So my recommendation is substitution in number 4 or in number 5, que contain only 2 variables to find the z value. Entonces, finally, well, okay, I see that. For example, I select in my paper, I select the number 4. And number 4 is 3 times x, que es 5, plus 2c equal 11. And 3 times 5 is 15, plus 2c equal 11. 2c is equal 11 minus 15, que es negative 4, divided by 2. Negative 4 divided by 2 es negative 2. C, no x, C es negative. Negative. So far, I have my solution 5, have no idea, and C is negative. I need to find the y, and that's it. To find the y, I need to come back in the original equation. I select, I don't know why, no reasons. You select another, you get exactly the same answer. I select, but I need to make a decision. I select the first, the second, or the third. When I select the second, I don't know why. Yeah, I copy 2 times 5, because x I know get 5, plus 3y, I have no idea who is y, minus, be careful with the sign, and the c value is negative 2. Equal 15. Be careful with the sign because the equation have negative subtraction. However, the value of the c is negative. So we have double negative. So 10 plus 3y plus 2 equal 15. Now we combine 3y, so 10 and 2 together is 12 equal 15. And 3y is equal 15 minus 12 is 3, no? Divided by 3, divided by 3, divided by 3, y1. Aye, no good. I lie. y1. Therefore, my solution is the order pair, let me write here in elegant way. 5, 1, negative 2. X, Y, and Z. Any question? Any question? Piece of cake or piece of rock?
Is there a reason why you use equation 2 over 1 to get the y?
Yeah, there are no reasons. So you select another, I promise you get the same answer. Do you want to see?
No, it's okay.
Okay. Okay, let's do one more example. We have time? Yeah, we have time. We're doing one more example. So you have no question. It's important to practice the procedure. You pair two equations and eliminate one variable. In this case, was one. In other example, I don't know. I have no idea. And you eliminate, and you pair another couple of the equation, and you eliminate the same This is the most important detail. Same variable. Same variable. Okay, sometimes you want to eliminate another. No, no. This example, the second example is classical. Que it's confusing because suppose 3x minus 2y plus c equal to equation number 1. 5x. Do you see what is the traditional way to write the linear system of equation? You put one column for the x, one column for the y, one column for the z. Sometimes it's present that way, but sometimes no. Entonces, when sometimes no, you need to manipulate some algebra first in order to express it that way. 1. But no, I don't want to complicate your life. At least in college algebra, you take with me pre-calculus to say now in pre-calculus you see more clear and more in detail that part. 7. Okay, this is equation 3, and this is my system that contains 3 equations and 3 unknown x, y, and z. For example, in my paper, I take the equation 1 and the equation 2. I have no idea why. I am free to do everything you want. This is equation 1 and equation 2. And the thing I try to do, using my experience in the next example, is, for example, multiply the first equation by 2. Why is the reason? Because 2 times c is 2c, and 2c positive and negative 2c positive. This is a one possibility, guys. Not always is the same. So I recommend that organization. You multiply 2 times 3 is 6. You put down, and you multiply 2 times negative 2 is negative 4y. And you multiply 2 times c is 2z, you put down, and 2 times 2 is 4. And this is exactly my equation 1 again. You forgot that. Because I focus in this and this. But no, I don't want to cross. In my mind, I cross. You adding equation 1 and equation 2. This is new, this is equivalent, it's equivalent. Well, no, I don't like the new word, it's equivalent. Okay, this is 11. This is 11. This is negative 3 because positive 1 and negative 4. And this is ready to elimination. And this is 5. And this is my new equation 4 that contains x and y because I eliminate z. There are no reason I eliminate z because I want. That was my decision. Okay, some people say, no, professor, well, you multiply by, let me see, by 2, the second, and you eliminate the y. You can, of course you can. Now, I take the equation 3 and the equation, the equation 1 and equation 3 now. I rewrite, recopy. 3x minus 2y plus c equal to, this is equation 1. And the equation 3 is 4x minus 3y plus 3c equal 7. No? This is equation 3. Okay, I put it here. I pair. But I know I need to eliminate c because in the first couple I eliminate z. In the second couple you need to do something in order to eliminate the same variable. This is the key idea. Well. This is C1 and this is C3, but positive both because you multiply this equation maybe by -3. By -3, it's a factor, it's the magic factor, -3. Because when you multiply, you get -9, so -3 and +3 is -9, -3 and -2 is +6, and -3 times +1 is -3z, equal -3 times 2 is -6. And this is my new equation 1 after the multiplication. Ready to combine. Equation 1, new, or whatever you want to call it, and equation 3. And equation 1, original history. This is 5, -5. This is -5. This is 3 because it's 6 positive minus 3 is 3y. It's gone like that. And this is 1. And this is my equation number 5. And you put together 4 and 5. And let's see what's going on. Okay, I put together like that. In the same column, in the same organization. Look. 3y equal to 1. And this is equation 5. I am looking, guys, because this is ready for elimination. Look, 11 minus 5 is 6. Elimination, this is a coincidence, and not always happen. Sometimes no, sometimes you need to enforce it. Exactly enforcing in the first equation, you enforce it in the second equation. And the right hand side we have 5 plus 1 is 6, divided by 6 both sides. X is 1. Boom. In order to find the rest of the unknown, is y and z, use substitution in the original. No, in the original, it's crazy. And the number 4 maybe, or number 5. I select in my paper number 4, I don't know why. 11 times 1, because I know the x is 1, minus 3y equal 5. I'm using here the equation 4. Okay, this is 11 minus 3y equal 5. Minus 3y is equal 5 minus 11. And 5 minus 11 is -6. Divided by -3, y is +2. Boom. +2. Okay, we almost finished. And the class is over when I finish. Okay, so in order to find the z, que is the remaining variable, I using the equation 1. I don't know why. I using the equation 1 original, this one. Entonces 3x, pero I know que 3 is 1. Minus 2 times 2, because I know the y is 2, plus c equal to 3 times 1 is 3. 2 times 2 is 4, of course, minus 4, plus c equal to -1, plus c equal to, sorry. Therefore, c alone is 2 plus 1 is 3. Wow. And where's my final answer? And my final answer is 1, 2, 3. If the order pair, I create intention like this example, 1, 2, 3. Remember, this is x, this is y, and this is z. Do you understand very well or no? Question? Clear? Confusing?